Hello friends, today we are going to solve the problem to determine the reinforcement details of column and its footing. So this is problem number 9, RCC column footing reinforcement details. Now before going to the problem, you should understand the skeleton of column with footing. Now the first footing, this is rigid spread footing, and one more, this is second, that is flexible spread footing. Now it will be having, see, there are three basic things will be there in a column. You will be having a footing portion, then you will be having column base. Over this column base you will be having the regular column. So three different things will be there, and you are supposed to find the reinforcement of mesh. This we called as mesh. This is hook mesh or column mesh. Then you will be having spliced bars which will be running from column base to the footing. Above two figures are centric figures, that is centric rigid spread footing and centric flexible spread footing. Now below these two footings are the example of eccentric spread footings. Now here you can see the different parts of the skeleton. Now you will be having the mesh, that is footing mesh. Then you will be having the splice bar here in this portion from column base to the footing mesh. You will be having splice bar. Then you are supposed to determine the vertical bars which will be coming from the roof slab to the column base, slab to the column base. Then you are supposed to determine the stirrups or binders. So three types of bar you are going to determine here. Actually four types of bars, right? Mesh bars, then splice bars, then vertical bars and stirrups. So four types of bars you are supposed to determine here. And that mesh will be consist of, see, it will be having a hooks, see, straight bars plus two hooks, right? So this is the portion that mesh will be having. These kind of a bars will be having into the mesh. So both the sides, both the direction, you will be having the main bars. Now here you can see this is the isolated spread footing and this is the stepped footing. This is also concrete. The skeleton will remain same, means column vertical stirrups will be there, then base will be there. In column base you will be having the splice bars. Again those splice bar are rested over the mesh. So the skeleton will remain same, only the outer structure will get changed. So that is how the things are there: isolated footing and stepped footing. Now we'll take an example and we'll solve the problem and we'll get the reinforcement detail. First I'll read the problem in short as much as possible. Then figure shows the plan and cross section of a following slab with a square RC column 20 cm outside with the following particulars. The column size is 20 cm by 20 cm above the plinth. Then the particulars are given about the base slab. That base slab is a footing slab. That is, area of a base slab is 1 meter by 1 meter. Area of a base of column is 28 cm. This base of column will be there in the plinth, right? Then depth of slab of a column face is 40 cm. Depth of slab at the outer edge is 15 cm. Then reinforcement into the slab is 16 cm dia bars laid in the both the directions. 16 mm dia bars laid in the both the direction at 15 cm center to center. Now here you will be having the mesh details, that is 16 mm dia bars will be there and those are laid in both the direction with a spacing of 15 cm center to center. Then column reinforcement details they have given. Now you can see that you will be having 4 columns of 16 mm dia bars and you will be having the binders of 6 mm dia bars with a spacing of 18 cm. Here you can see that spacing of 18 cm. Then clear cover is given, that is of 50 mm to the column. Clear cover for the slab footing, that is 50 mm, and to the column is 25 mm. Then other particulars as per the drawing, that is weight of 16 mm dia and 6 mm dia bars are 1.58 kg and 0.22 kg per meter respectively. Now you are supposed to prepare the that payment details or the bill of payment, means abstract you have to prepare, but I'll be solving this problem, or I'll be doing only the measurement sheet. Abstract you require the rates. If you are having the local market rates, you can go for the abstract also, there is no problem. Now we'll go to the step by step. Right, now we'll go to the step 1. Now before going to the step 1, you just see this along with this problem, this cross section they have given. This is the total top view of a column. See, you will be having a column size of 20 by 20 here. See this 20 by 20, and as you look from the top, you can see the base dimension also, the outer base dimension also. Here this is the outer base, that is of 28 centimeter into 28 centimeter, that is going to be into the plinth. Now this 20 by 20 here, this column size here you will be having 20 by 20, and the 28 by 28 here you will be having 28 by 28 at the plinth level, right, that we called as column base. And you will be having 4 diameters. See, 4 number of bars of 16 mm dia. Here you can see 1 number, 2 number, 3 number and 4 number. 4 number of bars are there. And you can differentiate the bars, as I said that here this is the mesh. In the mesh you can have straight bars, you can see the straight bars, so these we call them as type A bars, so they will be having in both the directions, so these will be the type A bars. Then second type of bar is this we called as splice bar, that is going to run from, see, from column base to the mesh, right, that we call as what, splice bar. And this splice bar is going to be overlapped with the vertical column bar. Now here the vertical column bar is going to run from here. Now this is vertical column bar, right, so this vertical column bar is going to get tied with the splice bar. Now this column bar is from from plinth, it is going to the slab, into the slab again it is going to be bent like this, right. So 2 centimeter it is going into the slab, then it is having a bend of 40 centimeter like this, right. So with these details you are supposed to go for the determination of bars. You can see the diameter dimensions here, it is this we call as what, base slab or mesh, hook mesh, right. So this base slab dimension is 1 meter by 1 meter, here it is 1 meter by 1 meter. Then you will be having, see that different depths will be here. This height is of 15 centimeter, right, here that height is given here. See, this is 15 centimeter, this height is 15 centimeter. Then this coned portion, see, from here to here it is 25 centimeter, right. Then above that up to plinth, here this portion is 45 centimeter. Then above plinth 60 centimeter portion will be there, right. So this is 60 centimeter free lock portion, we call it as 60 centimeter portion will be there. Over that up to slab you will be having 3.4 meters portion, right, here it is given 3.4 meters portion. Now with these details you are supposed to determine the 4 different types of bars. First bar, straight bars of the mesh, right, and second one is vertical bar which is coming from the slab to the column base. Then third bar is splice, column splice. Then one more, that is stirrups or the binders you are supposed to determine. Now here you can take 1 meter by 1 meter base slab size, 1 meter by 1 meter, and it will be having a cover of 50 mm both the side, this side and this side. Now it is very easy to determine the straight bar. See, the outer distance is 1 meter as I have shown here. Then deduct both side cover 50 mm and 50 mm. Then you are supposed to add 2 hooks, both side 2 hooks. Those 2 hooks will be 2 times of 9D. About the hooks I have given the note previous class also. So here also I have written that note. See that first, if you are having a round hook, then you are supposed to add 2 times of 9D. And if you are having a L hook, then you are supposed to add 2 times of 6D. That what I have did here. See, this is L out distance minus 2 covers plus 2 numbers of hooks. So it is going to be 1 meter minus 2 times of 0.05 plus 2 times of 9 into 0.016. So it is going to be 1.18 meter. So straight bar length is 1.18 meter. Now you are supposed to determine the numbers as the spacing is given. Here you can see that numbers of straight bars. So total out length minus 2 covers divided by spacing plus 1. So it is going to give you the number of total bars. So here I have written that calculation: 1 minus 2 into 0.05 divided by 0.15 is the spacing, plus 1. It is going to give you the 7 number. You will be getting the 7 number. So this 7 number is for one direction. See, this 7 number is for one direction, right? In this direction you can lay the 7 bars. Then you are having same dimensions, so you can get the same number of bars in this direction also. So total you will be having 2 ways. So both way you are supposed to have the bar. So it is 7 into 2, 14 numbers. So total number of bars are 14 numbers in both the direction. Now we are going to determine the type B type of a bars. B type of bars, you can take vertical column bars as a B type of a bars. There is a no sequence. You can take any type of a bar as A, B, C, D, right? But what I'm going to do is that first I'll be taking a mesh bars as a type bar. Then second type of bar, the length of vertical bars from roof slab to the column base. From roof slab, see, from roof slab to the column base. So these bars I'll take it as what? Vertical bars. See, it is going to start from here and then it is going to come up to the base. So this length I am supposed to determine now. Now it is very easy. From the cross section I have written the dimensions here. See, this is the the base dimension 45 centimeter. Then after the plinth you will be having 60 centimeters of a lapping distance, right? Then 3.4 is the distance above 60 up to the roof slab. Then again this bar, it is going 20 centimeter into the slab, then it is bending here up for a 40 centimeter, right? So total length, it is very easy. See, this you have supposed to take this 40 plus 2, then plus 3.4 plus 0.6 plus 0.45. You are going to get the total length. That what I have shown here. The length of vertical bar, that is 0.45, this plus 0.60, this plus 3.4, this plus 0.02. that what it is inserted into the slab up to 2 centimeter. So you are having 4.47 meters, right? But as I said that this bar, it is going to be bent in this direction and in this direction, right? So it is going to bend in this direction, as this bar going to start from here, it comes up to 2 centimeter, it enters 2 centimeter to the slab, then it is going to bend in this direction. So it is that you have to add that extra 40 centimeter there. So that I am adding here to this total length, adding 40 centimeter anchorage as shown in the cross section, that is 4.47 plus 0.40 meter, it is going to be 4.87 meters. Now this is the bars. So no need of determining the number of bars, because in the problem only they have given that 4 number of bars are there. See here, 4 number of bars. Into the corner I have shown that cross section right here. So you'll be having 4 numbers. So it is no need of determining the numbers there, right? Now here I am going to determine the length of splice bar. A bar now from footing base to the plinth level. Footing base, see, this is from footing base to the plinth level. This bar I am going to determine, right? Now here you can see that this we call as type C bar, and from the main figure which they have given, from that I have I noted down the dimensions there. I am showing it as in a separate thing, right? So separate cross section I have shown. So you're supposed to add that dimension, right? It is very easy. See, this L is given, hook is 40 centimeter, it is given, right? This hook is 40 centimeter. Then the dimension, now see this portion is 15 centimeter, which is shown in the cross section. Then this is the tapered portion is 25 centimeter. Now that total base is of 45 centimeter. Then after this plinth level, up to plinth level, then that splice bar, it is going to be erected into the main column as a lap of 15 centimeter, right? You can see into this figure here, it is that lapping is given for the main column of 15 centimeter. So if you add total length from this bend to up to this, so it is going to be the total length of that zone. So I have tried it to determine here. You can see that first, see, the very foremost thing you are supposed to do, you are supposed to start. Now you are not supposed to take it from 15 centimeter. Why? Because that bar is not coming down to the footing bed. Now you will be having a mesh. Over the mesh it has laid, right? I'll show you in clear picture. Here it is. Here you can see this, right? That bar, it started from here, right? So you have to deduct this much length. This much length you are supposed to deduct. What are things will be there in the deduction? See how to deduct that. You are supposed to take this 15 centimeter. In this 15 centimeter you are supposed to take the deduct the cover. This cover you are supposed to deduct. Then you are supposed to deduct the dia of this bar. Then you are supposed to deduct the dia of this bar. So you will be deducting 15 plus 16 plus 16 mm. So this much deduction you have to do into the 15 centimeter. Then you will be getting the height from where you are supposed to start the to measure the splice bar. Now that I am going to show here. See, this 15 centimeter minus 50 mm minus 2 bars, right? So 2 into 16 mm, then plus 25 this, plus 45 this, plus 15 this, and plus 40. Now which 40 is this? See, here I have written plus 40. Now this is this 40, that L bend 40, right? So we'll see how much it will be there, right? So it is 0.15 minus 0.05 minus 2 times of 0.016 plus 0.25 plus 0.45, 0.15 plus 0.40. So it is going to be 1.318 meters. Now I rounded it for the 1.32 meters. So this is the length of splice bar. So here also no need of providing the number of bars or determining the number of bars, as you will be having the same number of bars as you will be having the bars into the columns. But one thing I'll tell you, that how the location, how they are going to erect it. Now they are going to laid along the into the mesh along the that taper direction. I'll show you into the main figure. Now see, the splice bar is coming like this and it is going to be bent like this. Now that bend here, it will be like this, right? 4 splice bars, you can see this, right? And here it has given 40 centimeter. You might be asking from where I have taken that bend 40 centimeter. It is given into the figure, right? So that's how you have to supposed to take these splice bars, that 40 centimeter L bend. Now coming to the D type of bars. So these are the stirrups. In last problem, in previous problems also, while solving the beams, I told you how to get that. You'll be having outward dimension. You are supposed to get the in-twin dimension, right? So that in-twin dimension plus 24D, if you add, then you will be getting the total length of stirrups. That is inner depth plus inner width. Then 2 times of inner depth, 2 times of inner width plus 24 dia of bars, right? So that what I am going to determine. See that out depth is 20 centimeter, out width is also 20 centimeter. Then you are supposed to determine the B effective and D effective. That is effective width by deducting the covers and effective depth by deducting the covers. So first I am going to determine the inner depth, that is D effective. So overall depth minus 2 covers minus 2 into dia. Now I previous class also I told that, see, if you deduct covers only, that much will be sufficient. But why I am going to deduct this 2 times of dia? Because as I said that if you see the section here, so that section will not be exactly at the corners will not be exactly sharp edges. There will be a small you will be having the you can observe a chamfered cut there, or you can observe a bend there, right, like this. So it is not going to be a sharp edge. If you will be bending bar in the sharp edge, then no need of deducting this. But no one can bend in that direction. Whenever you will be bending the bar, then you will be getting it in a, see, you will be having a smoother bend there. So you will be deducting that here, right? For that you are going to take 2 times of dia. So 20 centimeter minus 2 covers minus 2 times of dia. So you will be getting here it is 0.138 meters. So I'll be rounding it up for 0.14 meter. So this is the only the inner depth. Now for inner width, same criteria I'll be following here for the inner width. See here, overall depth minus 2 covers minus 2 into die of bar. So here also the dimension is same, so you will be getting the same inner width also, that is 0.14 meter. Now here total length of stirrups 2 times of inner width plus inner depth in plus 24 times of die of bar. So inner width is 0.14 meter, inner depth is 0.14 meter, die is 0.006 meter. So 24 times of 0.006 you have to add. So you'll be getting, see, 2 into 0.14 plus 0.14 plus 24 into 0.006. So you'll be getting 0.70 meter is the total length of stirrup. Now you are supposed to determine the number of stirrups there, as that number of stirrups is not given in the problem. So overall height you are supposed to take divided by spacing is given, plus 1 you are supposed to do. If you do this, you will be getting the number of stirrups. So overall height, see, you are supposed to start from the tapered portion, right? I'll be showing into the figure. Now see, you are supposed to start the stirrups from here, right? Then above this, see, means you are supposed to take this 24 plus 45 plus 60 plus 3.4. If you add this, you will be getting the total height. Now this total height you are supposed to get, then divided by spacing. If you do that, you will be getting the number of stirrups you are supposed to get, right? So this the formula is very simple, that total height divided by spacing plus 1, you'll be getting the total number of stirrups. Now here I have shown you that, see, overall height, that is 25 plus 45 plus 60 plus 3.4 meter, that I have written here in terms of meters, divided by 0.18 meter, that is the spacing they have given, plus 1. So you are going to get 27 numbers of stirrups. So length is 0.70 and the numbers are 27 numbers of stirrups. Now step number 5, after determination of column bars, you are supposed to determine the concrete quantity also. So here you can divide this column footing portion into the 3 different steps. Now you will be having, see, this is a footing base, then you will be having a trapezoidal portion here, tapered portion, then you will be having a column base. So 3 different sections are there, so you can easily determine the 3 different volumes or quantities for that. Now first I'll be getting, see, this footing base portion, that is base slab. So the size is 1 meter by 1 meter into height is 15 centimeter. So it is 1 meter by 1 meter into 0.15 meter. So you'll be having 0.15 meter cube. This is the quantity for this base portion here. This is the base portion here, right? This portion you are going to get the quantity, that is 0.15 meter cube is the quantity. Now for the this trapezoidal portion or tapered portion, you will be having, now you can see that you can use the trapezoidal formula here, h by 6 into a1 plus a2 plus 4 times of am. So a1 is the area of bottom portion is, see here, if you see this, right, here you will be having bottom portion, that is 1 meter by 1 meter. Then you will be having area of upper portion, this is upper portion, right? Here will be having the 0.28 into 0.28, that is 0.08 meter square. Then you will be having the average, right, average of both the areas, that is 1 plus 0.28 divided by 2 whole square, that is going to be 0.41 meter square, right? So here you can see that 1 by 1 is the bottom portion and 0.28 by 0.28 is the upper portion, right? And mid area you are supposed to get 1 plus 0.28 divided by 2 into whole square, that is going to be 0.41 meter square. So if you put these things into the formula, it is h is height is for that tapered portion, height is 25 centimeter for that tapered portion. If you see the cross section, you can see that this is 25 centimeter, right? So that is 0.25 divided by 6 plus 1 meter square plus 0.08 meter square plus 4 times of 0.41 meter square, it is going to be 0.113 meters cube, right? So this is the volume of trapezoidal portion, right? See, all these quantities here are the meter square, and that is going to be multiplied with meter, so you'll be getting meter cube. Now the column base, the size is 0.28 into 0.28 into 0.45. So the column base is here, you will be having the 0.035 meter cube, right? So this is the main 3 portions of the footing. Now the fourth portion is total column which is above the plinth. Fourth portion is total column above the plinth. So that also you have to take. Here I have shown this. This is the total column above the plinth. So here the size is that is 20 centimeter by 20 centimeter into 4 meter. 4 meter is the total height. So that 4 meter height, you can easily measure. So that height from the column, see that above the column it is 0.6 plus 3.4, it is going to be 4 meter, and the size is 0.2 into 0.2. So if you multiply that, you will be getting 0.16 meter cube. So total portions means 3 parts of the footing plus 1 part of the column above the plinth. So that is going to be total. Now here the total quantity of concrete is 0.113 plus 0.150 plus 0.035 plus 0.16, that is going to be 0.458 meter cube. Now this is the total concrete quantity. So see, you are going to determine the steel quantity, concreting quantity, and shuttering also you are supposed to determine. Now here you can see the shuttering. Shuttering again you can divide into 3 different sections, that is sloping trapezoidal portion, then column base, and the vertical column, right? Column at upper column above the base. Now the first one is sloping trapezoidal portion, that is 4 sides into mean of top and bottom into side slope. So here you will be having 4 number of sides. That mean is 1 plus 0.28 divided by 2. Then side slope is 0.25 square plus 0.36 square. Means, see, I will be showing you that portion here, right? Now this is you can see that this is 0.25 you will be there, this dimension, and this dimension will be there 0.36. I'll be showing you how that 0.36 is going to be there now into the main figure, right? Now if you take the size of column base, see here this is 28. Now this is 28. Now if you take this 0.28 here, 0.28 here, so 1 meter minus, if you deduct this 0.28, so remaining the total remaining is 72. So 72, half of 72 will be here this side, and half of 72 will be here this side. Means 36 will be here this side, and 36 will be here this side. So the portion will be very clear here. Now this is 25 and this is 36, right? 36, 72. So it is very clear now, right? As I said that, right? See, this is the 28 here. If you bring this 28 here down, so this is 1 meter. If you deduct this 28 from 1 meter, you will be having 72 portion, which is going to be divided into 2 separate portions, right? 72 divided by 2, the 36 this side and 36 this side. That 36 I have shown here, right? So that is 4 into 1 plus 0.28 divided by 2 and square root of, because you want that inclined portion, right? You want this inclined portion. So that is going to be 0.25 square plus 0.36 square. So it is going to be 1.12 meters square, all 4 sides, right? Then column base, it is very simple. That column base, see, column base will be like this, right? We'll be having 4 sides. So column base, see, 4 numbers, 4 sides, right? 4 sides will be there into 0.28. 0.28 is the dimension of one side. So 4 sides are equal 0.28. Then you will be having height is of 0.45. So if you multiply all those, you will be getting 0.50 meter square, right? Then column, see, it is very simple. That column is having a size of 20 centimeter by 20 centimeter and height is of 4 meter, right? So 4 sides into, what is there, 4 sides into 4 sides into 0.2 into 4 meter, it is going to be 3.20. So it is, see, if you add all those things, you will be getting 4.82 meters square. This is the total shuttering quantity. Now you are supposed to prepare the bar bending schedule. Here you will be having a bar bending schedule. That is, you can see that A type of a bar, 16 mm dia, straight bars with the 2 hooks. The length we have got, that is 1.18 meter. Numbers, so you'll be having 14 numbers, 7 and 7 both direction, 14 numbers. So 1.8 1.18 into 14, you are going to get 16.52. Now this 16.52 is going to be multiplied by weight per meter bar that is given in the problem, that is 1.58 kg per meter. So 16.52 into 1.58, it is going to be 26.10 kg. Similarly, B type of a bars, so here you can see that B type of bars, 16 mm dia, you will be having, as I said, that this is vertical bars, no, from roof slab which is coming to the base. The length, the height is 4.87 meter, 4 numbers of bars. If you multiply 4.87 into 4, you will be getting 19.48 meters. That you are going to multiply with 1.58 kg per meter, so you will be getting 30.77 kgs. Then C type of a bar, here you will be having the dia is 16 mm, that we call as splice bars. So the length is 1.32 meters, 4 numbers of bars. If you multiply 1.32 into 4, you will be getting 5.28. If you multiply this 5.28 with the weight per meter, you will be getting 8.34 kgs. Now all these 3 types of bar, A, B, C, are of 16 mm dia, so you are going to multiply with 1.58 kg per meter. Now this total of this is going to be 65.21 kgs, right? This is total quantity of 16 mm dia bars. To this you are going to add the stirrups, as the weight is totally different, so we have separated this quantity. D type of bars, 6 mm dia, and this is how it looks. Then length is 0.70, 27 numbers. So if you multiply 0.70 into 27, you are going to get 18.90. Then the weight, if you multiply 18.90 into 0.22, you are going to get 4.16 kg. Now if you add these two things, that is 65.21 plus 4.16 kg, you are going to get the 69.37 kgs, or in tons if you want, it is going to be 0.69 quintals. Sorry, in quintals it is going to be 0.69 quintals, and in tons it is 0.06 tons. And now for further this one, I am going for the next sheet. This is the bar bending scheduling, and the next sheet is measurement scheduling, right? The measurement book, MB book. So you will be having that measurement there. All together means you are going to supposed to write the bars, you are going to supposed to write about the concreting quantity, and you are going to write supposed to be shattering quantity also. Now the step number 8, that is measurement sheet. You will be having, see this, the particular numbers, length, width, depth, quantity, and remarks will be there. So first is concreting, cement concrete 1:2:4 without reinforcement. Quantity we have determined in step number 5. You will be having the quantity of 0.458 meter cube. And shattering, see, in step number 6 we determine this quantity, that is 4.82 meters square. And for steel reinforcement, in step number 7, if you see the bar bending scheduling, we have got this quantity, that is 0.069 tons, 0.69 quintal, that is nothing but the 69.37 kgs. If you are having the market rates, then you can prepare the abstract, that is nothing but the bill of payment, right? So if you are having the local rates, you can go for abstract also. Well friends, that is what from my side. I am Professor Balasaheb Jamadar. Thank you.